Hi guys, this is Sajjad Hussain again with a new video. Actually, this video is in continuation of my last video. If you see my last video, I analyzed a 12-story building. You can see this is the sample of the 12-story building. The dimensions are given over here. Height is given like this, and service loads are defined like this. Superimposed dead load is defined like this, and the seismic and wind design parameters were given like this. So in last model, what I did, I took the seismic design parameters and used the STAAD seismic load generator, and we checked and found that the load generated by STAAD is in line with the calculated values here. Now in this case, we are going to check the wind load generator of STAAD. We will use the wind load data which is given over here, like the basic wind speed, which is 145 mile per hour. Its exposure category is B. For category 1 occupancy, the value of I is 1. So wind load analysis as per this example is as follows. They say that according to IBC 1609, wind forces shall be determined in accordance with section 6 of ASC 7, which is the same as IBC. Since the building has a mean roof height greater than 30 feet, the simplified procedure, which is called the method 1, given in section 6.4 of ASC, cannot be used to determine the wind forces. So similarly, the simplified procedure of IBC 1609.6 must not be used, since the building is taller than 60 feet. So what we have to do, that we have a detailed design procedure over here. We will adopt the same design procedure. Of course, it is adopted by STAAD, and we will see that the wind forces generated are in line with these calculations. So all these parameters are given over here, the basic wind speed, KD, etc. and etc. So basically there are two directions, the north-south direction. Let's see the figure. So here is the north-south direction. That means as per STAAD coordinate system, north-south direction means in Z direction and east-west direction means in X direction. I will consider only the wind load in X direction. Of course, wind load in Z direction will be the same. So if wind load in X direction is in line with the calculation given over here, so we will assume that the wind load in Z direction or in north-south direction will be the same. So it will give us a confidence that the wind load generator of STAAD is in line with the manual calculation. So basically this is the idea. Let's proceed. We will go to the procedure to calculate the wind load in east and west direction, or which is the X direction for us. As you can see here, the windward wall CP is given as 0.8, and on leeward side, since L upon B is 2.7, so CP comes out to be 0.26. I'm not going into details of calculating the CP value and this, because all the references are given and everyone knows how to calculate these values. For side wall, CP is 0.7. Since roof height is 148, so H upon L is equal to 0.8. So the roof will have different sort of pressure, and it will be CP is 1.14 with a negative, CP will be 0.78 negative. for 74 to 148 feet, and later on it will be 0.62. So let's go to STAAD and see what happens if when we apply these loads. Let's go to general, load definition. Let us define the load. Wind load definition. Let us add the type 1. This wind load type 1, it should be windward load in X direction. Okay. So let us define the load first. We will follow the ASC 7 procedure. We will not be using 2010. That's another debate why we cannot use 2010. We will be using 2002. Here the exposure category given. The building is classified as category 2 building. Somewhere it is written. Anyway, it's there that this building is categorized as category 2 building. Here. Here, if you see that the importance factor W as noted above, IW is equal to 1 for category 1 occupancy according to IBC table dash and category 2 occupancy according to ASC 7 table 1. So basically this is the equivalence over here, that if we are following ASC 7, we have to define this as category 2. So anyway, we will go to our definitions and we will define windward load. So this is a category 2 building. Wind speed was 145 miles per hour. The exposure was defined as exposure B. And this is a building structure. Consider wind speed over hill or escarpment. No. Okay, so we should apply over here. Then go to main building data. The height of the building is 148 feet. The length of the building along the direction of the wind, this is 184.33. Length of the building normal to the direction of the wind, which is 68.33. The frequency of the building, if you remember, it was 1.27. Damping 0.05. It is an enclosed building. And we should use importance factor as I. KD, instead of 0.85, it is suggested to use 1. Let's apply. Building design parameters. So the value of G as calculated was 0.85. if I remember correctly, in east-west direction. Let us confirm. Yeah, in east-west direction, the time period came out to be 1.27, and G in east-west direction was calculated as 0.97. So let us take this value. Value of G is 0.97. CP is considered as 0.8, and GCPI is minus 0.18. Apply. Okay. Add. Of course, the importance factor is 1. We have to add this one. Let's assign to view. Okay. Assign. Okay. Now we have to define again the wind load for windward direction, leeward direction, leeward in X direction, so same procedure. We cannot use 210, category 2, 145. Exposure is B. This is a building structure. Apply. The building data 148. Along this wind direction is 184.33. Normal to the wind direction is 68.33. Frequency is 1.27. Damping ratio is 0.05. It's an enclosed building. I is equals to 1. KD is equals to 1. Supply. Then go to the pressure. This was as the leeward direction, and for leeward direction, as we applied before, G was 0.97. For leeward direction, this CP is minus 0.26, minus 0.26, and GCPI is equals to minus 0.18. Let's apply. Okay, so add. Factor is 1. Close. Intensity assigned to view. Okay. Now the third is sidewall case. We have to add side wall when the wind is in X direction. Let's add. Again, same procedure. 2002, 145. Apply. Building data, height is 148, 184.33, and in another direction it will be 68.33 as before, 1.27, 0.05 as an enclosed building, I is equals to 1, KD is equals to 1, apply. And this is the side wall, 0.97. CP for side wall is minus 0.7. GCPI is minus 1.18. Apply. OK. Add. Of course, the factor should be 1. Add. And this is assigned to the view. So let us save. Now let us define the load cases. Add. Let us define the load as a wind load. Wind load in X direction. Let us add. Now add first wind load. We know that we have defined windward, X factor is 1. The range of the building is from 0 to 148 feet, and this load is applied on the windward side, so that means the range of X will be 0 to say 1 feet. Okay, add. So wind is flowing from our left hand side, so this is the wall which will be facing the wind, so this is the load generated over here. Now second is, let us define the wind on the leeward side. Wind load, we defined load case number 2 as our leeward face, minus X. It will be range is 0 to 148 feet height, and the length of this building is 184.33, 184. So let us say 183 to 185. Add. Edit. No, I think if I selected leeward side, so I should not define this value. Change. Please enter a number is 0 and 0. Change. Yeah. So leeward side means this one already is defined. Now we have to add for side wall, again the wind load, load case number 3. And it should be in Z direction side wall. Range is 0 to height is 148. Now the Z direction is 0 to 1 feet, that means on the other side. Let's add and see. So that is the wind load applied, but it looks that there should be a negative sign. Yes, there should be a negative sign. Edit. This factor is minus over here. So that is the correct sense of the wind load. And similarly we have to apply for this side of the wall. Add wind load number 3, Z direction. This should be height 0 to 148, and now the maximum range is 68 in this direction. Let's say it's from 67 feet to 69 feet. Add. To leave this range. Change, enter a number 0, 0, change. So now this is the second force, which is the negative direction. Let's see the sense. Correct. So applying a negative pressure on the roof is nothing. We can apply a negative pressure. Let's see the pressure on the roof. The pressure in the roof is CP is we can ignore the pressure on the roof because this is a concrete building enclosed from all sides. Roof pressure will have almost negligible effect on the structure. Let's see what happens. Let's save the building model. Let us analyze. Done. Now the load is calculated here. This is in north-south direction. We have not considered north-south direction. This is the wind force considered in east-west direction, and these are the design forces in east-west direction when the wind load is 145 feet. We can see that at the top level the wind pressure in windward direction is almost 18 to 19 kip, and in leeward direction it is 6.2 kip. Let us see what is the result over here. So we can check here. To see the load values. So on this direction, at the rooftop, the highest level, the wind load are 3.75 kip over here and 7.5 kip here, 7.5 kip over here, and 3.754 kip over here. So if we add all these, 15 plus 18 plus 3, almost 21, 22 kip force is there against 19 kip. So it's in good combination, good agreement with the load value. We have calculated almost 22 kip. Here the value is 19 kip almost. And on the leeward side, the wind is 6.2. Let's see. On the leeward side is little bit less. Yeah, and these forces are small, almost 1 or 2 kip, whereas here this is 6 kip. So on leeward side it is a little bit lesser than the calculated values. It's maybe because of some of our definition. If we check it thoroughly, we can say that STAAD has given the wind forces which is in agreement with the calculated values. Sorry. So this is how we define the wind load on buildings. Just click this. We don't want. Let me close this model, and I completed this model, and I will show that one. This was the model, exactly the same thing, but later on off camera I did all the calculations and I input the values. Like here, the same seismic load in X and Z direction. This is dead load. All dead loads are defined. Oh, something wrong. Yes. It's from 16 to here, it will be 136. So let us change this one, 11 to 137. Change, yes. Okay. okay, I will delete all. So let me delete these loads which are not needed now. And let's edit this one. It is 147 to 149. Change, correct. Actually I shifted the origin and then I forgot the same thing. Okay, sorry. Let us edit over here, it will be very easy. So it will be from 11 to 137 minus 150 pound per square foot. I will delete all not needed and I will change this to 147 to 149. Let's save it. Right. And similarly I define the wind load cases over here. Let's run and see what happens. Fine. Let's see. Let's see the load values. Very difficult to understand. Because I already defined the wind load at the roof. So let us select all these nodes only. View selected objects only. Yeah, that's great. So now I can see that the forces are 3.754, 7.508, 7.508 and 3.7. When I add all these, so it comes out to be 22.58, whereas the calculation was showing 19. And similarly on the leeward side, let's see. Yeah. Now the leeward side is 2, 3, 4, 6, something around. It comes out to be 6.18. And what is here? 6.2. Exact. Thanks God. maybe I did some mistake over there. So that means I can confidently say that the load calculated by STAAD, especially the wind generated by STAAD, is in line with the manual calculation. Thanks God, we can safely use STAAD load generator for seismicity and STAAD load generator for wind loads. So here I conclude. Design of the structure is not an issue, big issue, because this building falls in seismic category A. And in seismic category A, there are no special requirements. Maybe I will design this building for other seismic categories like B, C and D, and we will see what are the implications. What are the additional requirements which we meet when we shift from seismic category A to B, B to C and C to D. That is very important. This is the all related to the seismic detailing. That will be very important. This is a simple ordinary building lying in an aseismic area, so we need not to do, just we have to comply with ACI 318 code. That's it. Hopefully you will like this video, and you will subscribe my channel. Thank you very much. Bye.